Hi, I'm Eric Wooldridge, and welcome to SCC's Additive Manufacturing Lab, where we house both our pre-engineering program and our worker course in 3D printing. We're going to take a quick tour to kind of show you what's going on. In the room that I am now is actually our Cad modeling side of things, because for us to 3D print anything, you have to do a computer model. So what you see in the lab is just your basic computer setup, normal workstations. We do try to do dual monitors with everything that we do, so you can actually see material for learning and actually do the action on the screen as well. And behind me you see some basic FDM printers, some desktop models where we do a lot of our low-cost applications, including our metal 3D printing work in low cost. So you have a normal space where you can actually expand and do a lot of different work, and you can put a lot of equipment right out in the open for students to actually tinker with and kind of interact with. But the real magic of it is the fact that by opening up this process, we let our students create all sorts of things. Everything from exotic shapes to complex components, doing plastic chainmail, all the way to advanced topology optimization, using in topology, generative design, and that sort of thing. So in this lab, it's all about the computer power and the advanced software, the artificial intelligence that can create advanced designs, because that's the key. The printers are one thing, but it's the advanced design mentality. And we have a lot of things on display in terms of student work. We like to show folks what students can create and what industry might be interested from that work. And over here you can check out some of the samples that we have. We put a lot of it on display for folks to see as they come through, showing everything from the metal applications to the super complex components. Other applications include our work in doing 3D printing for injection molding, the ability to actually print objects that will be used in injection molding processes. For example, the molds can be 3D printed for short test runs, and we show students how that process works. And we expose them a lot to generative design. So instead of students designing simple things like shelf brackets, we will actually have them design the basics and then let the generative take it from there. Because this is the next generation design technology where artificial intelligence is doing the work that we couldn't do in essence. And so it's letting them do that at an early stage. So a lot of our students, when they go through the program, they are actually pretty advanced in generative design. Overall lab will typically involve your projectors, your TVs, your especially virtual conferences that we work with on students, and actually hold tours and also speak at presentations in this kind of fashion. And if you'll kind of go with us this way, another application that we're also breaking through in this case is the fabric printing, where we can actually take a low-cost printer and turn it into a textile producer. Sorry about that. And we'll really expose it to the ability to use exotic materials in this process. Everything from electrical production, 3D printable circuitry, all the way up to wind power and solar power generation is involved with this technology. So our lab is just full of things that not only catch the eye, but demonstrate why additive is different. Even some of the free samples that we give out have moving parts that were printed in place. So let's step on into our other room. So in here is where we do our polymer additive manufacturing. It doesn't take up a whole lot of space, and you can see over in this direction we generally have our printers set up in racks for a 3D printer format where we can actually turn it all on and scale up to a higher volume production. We also include a lot of different lower cost applications. We do have some equipment that can go into the high temperatures. Even though it's considered a low-cost piece of equipment, it can go up to 400 degrees Celsius, and we can print in the more exotic and stronger materials. So there's a lot of applications that people don't realize are possible in the low-cost format, and low-cost is the best educational format, because the same technology can be represented in something that costs less than $400 as is applied in a machine that costs $100,000. We also involve ourselves with the SLA, the DLP type systems, where you're taking a resin, hitting with a certain wavelength of light, and you end up getting a hardened part. And so this actually is a generative part we have recently designed. I believe I actually have one right here. And so this is an FDM version of it, and we are turning around and using an SLA to turn around and produce it as well. So the process is a little bit different between the two, but again, it's all about the software. Now, material testing is a huge part of this, because at the end of the day, you have to validate your results. And what we focus on is making sure that students understand some of the basics of material testing. So we keep some decent equipment. We have our typical compression and tensile tester here that we use to test out parts. Nothing major, but enough to get the understanding of what's going on and also get some pretty good data. We also do hardness testing go with it as well in some of our other labs, and of course we'll throw the microscopes to it to see the grain structure that we're dealing with. So now we'll head up and check out some more industrial equipment and see what's going on up there. So we also incorporate annealing and sintering into our work because there are materials that can actually be printed on a low-cost machine and then sintered into a solid metal object. And cleanup is always a big deal. And here we have one of the more advanced polymer systems. And this is the HP 540. Now this is considered an industrial polymer printer. It's the smaller version of the 4200 system. And it's basically what the industry is looking at right now for polymer production. High precision level, good quality material, no Z-axis weakness, and also high volume. So for example, we can load this thing up with all kinds of parts for multiple different applications and let it print overnight. It runs itself. The next day, pop it open, clean it out, use some blaster, use basically a micro peening process to actually clean it off, and then there you have your part. So this is what industry really loves to see, that step up to the industrial level and the higher volume applications. This machine is quite capable of doing hundreds, if not nearly 1,000 parts, depending on size, overnight in one run. Back here, we have our typical SLM system. Again, SLM has a little bit older technology, much more proven, much more accepted right now in terms of many industries. But basically taking powder, metal powder, putting it in, hitting with a laser, and fusing it together. So this technology is actually used for not only training, but also exotic materials. Our system can do titanium, aluminum, we do a lot of stainless steel, it can also do Inconel. A lot more settings go with it, and a lot more hazards. For example, we have to actually pump this down with either argon or nitrogen just to get the oxygen out for a correct burn and to keep things safe. Follow that up with, again, another micropeening system, and therefore we have our finished part. So we use this technology not only to train and show students how it all works, but also just to help industry understand the differences in the technology. And this is a really good system for students to get in there and sort of get their hands dirty without being a black box approach. Now after the metal parts are done, we can actually post-process with additional CNC processes, typical grinding, finishing, belt sanding, whatever the case may be, and we can provide that over on our conventional side next to us. So any good manufacturing process involves both the new advanced sort of thing and also the conventional. And in this is our conventional machine tool lab. And you can see kind of from around, we have everything from your more new CNC lathes all the way down to your conventional belt sanders and cutters and grinding tools. Because you have to be able to understand it both, especially if you're going to be working in metal additive, because that's that post-processing that goes with it. So students will actually learn how the original stuff works, and they'll also learn how the new stuff works.
Hello, my name is David Selvage. I'm an additive manufacturing instructor here at SCC, and now we want to showcase some of the technologies that we're working on and trying to wed with our 3D printing technology. Here we have an industrial laser cutter. We're able to cut material like wood and acrylic, pretty much anything that we can 3D print, we can modify or cut with this laser cutter. One of the new things that we're very excited about is our ability to 3D print using low-cost FDM machines, this almost like fabric-like mesh, and we're able to cut it with our laser cutter. Here's another piece of equipment that we're excited to showcase. This is our injection molding machine, and you might wonder where the relevancy is with injection molding and 3D printing. But one of the things we like to talk about is, yes, injection molding still is the most efficient way to mass produce small parts. However, the upfront cost is very expensive. So our goal is to be able to 3D print the molds to use in the injection molding machine. And while that still has its limitations, not every student can do that, we can print some generic molds, and our students come in here and get hands-on experience with this piece of industrial technology, and it just helps prepare them for the workplace ahead.